will be learning about genetic variation. Everybody, please take out your workbooks.
Again?
So genetic variation is the science of how the genes It's the beginning of the tour.
Huh? How did I get here?
So we will be starting our presentation on genetic variation. As you can see in this exhibit, there are many different kinds of bears, and they have a very complex gene pool.
Oh, okay.
Do you know what a gene pool is?
No.
Well, the gene pool is the amount of genes in a population at a given time. See, there are plenty of different genes here, like the black and white gene, the brown gene, the white gene, the purple gene, and the blue gene.
I thought jeans were pants.
No, we're talking about genetic material genes.
Oh.
See, there's also a thing called relative gene frequency, which is basically like the amount of alleles that are there at a given time. As you can see, the most common gene is the black and white gene, with 4 in the population with that gene.
Cool.
Sometimes things in genes happen which are called mutations.
Wait, mutations? I know what that is. It's like, you know, when genes change, right? When it's a permanent change in the gene, and then it can be passed down to other offspring.
Yeah, pretty much. Mutations can be passed on from generation to generation. As you can see with these tigers, the white tiger is white because of mutation in its genes. Its parents were also white tigers, which means it's a white tiger because of the recessive alleles. I learned about mutations, but they can be decreased in likelihood due to genetic shuffling. As you can see, when these two organisms mated, their genes shuffled and combined so that they could produce 2 genetically different offspring.
So it's like when you shuffle cards and then you take a jack out.
Not really.
Oh, no.
This exhibit is about polygenic traits. As you can see, these animals are very big. Their size is a polygenic trait. It's controlled by different genes and different alleles on different parts of the chromosome.
How many genes?
It depends on the organism. For example, humans have 3 different genes with 6 different alleles.
Oh, that's really cool.
Now this exhibit is on directional selection. We'll be using these dogs as models. See, as you can see, a long time ago there were big dogs, medium dogs, and little dogs. However, because of natural selection, the middle dog dies out, leaving these 2 extremes to mate, creating a whole different gene frequency.
Wow, cool.
So are we using these again?
Yeah, but this time we're showing stabilizing selection.
Oh, that's when the extremities they die off, right?
Yep.
Oh my gosh, so aggressive.
Yeah. See, the middle one remains because of natural selection, creating a status quo.
So nothing changes.
Well, the extremities die off.
Oh yeah, but like it's still there.
Yeah. Okay.
Oh look, 3 more. Are they models too?
Mm-hmm. Now this one is going to show genetic drift. As you can see, there is 1 dark puppy and 2 light brown puppies. However, when a crack between worlds comes and a shift happens, they both separate. However, since there's 2 light brown dogs, they can reproduce within themselves. However, the dark brown one is lonely and dies off.
Forever alone.
Mm-hmm. Forever alone.
Oh my gosh, look! That's mama and its baby.
Yeah, this is an example of genetic equilibrium. The rabbits will remain the same size throughout its population, creating an equilibrium where everything is the same.
That sounds really sad.
Yeah, it's sometimes good and sometimes sad. It's sometimes sad because a predator can take out all of them at the same time.
Oh. That's terrifying.
Mm-hmm.
Cool. Oh, look, bears! Those are my favorite animals.
This exhibit is used to represent the founder's effect. The founder's effect is when there are many different types in a species, but through a genetic bottleneck, some of them die out and almost like recreate the species.
So, like, if a fire came and the pandas were, like, all in water, then they survive and everyone else dies?
Yep. Yep, see, this is what happens after. Now, all of the species will only have black and white in them. None of any of the other colors you saw earlier.
Are they actually dead?
Yeah.
Oh my gosh. Wait, so a fire just blazed through?
Yeah. Or any other natural occurrence. Even a predator could have just eaten all the other ones.
Please tell me those aren't real.
No, they're just models.
Oh my gosh. So, how do you know that evolution exists?
Well, we know that it can't not exist because of the Hardy-Weinberg Principle.
Okay, and?
So the Hardy-Weinberg Principle says that if 5 factors remain constant, then evolution does not exist. For example, large population means that like there's plenty of people in the population to mate. If random mating does not exist, then like gene shuffling won't exist.
So like this world.
If there's no immigration or emigration, that means the population remains constant with no changes. If there's no mutations in the genes, that means there's nothing changing about the genetic frequency. And if there's no natural selection, that also says that the population will remain completely the same. However, we know that all these things are not possible. Therefore, evolution has to be existing.
Oh. So like my teacher said, when the feet on the people back then, their tiny toenail was longer. And now our tiny toenail is like tiny.
Yeah.
Because we don't use it anymore.
Yeah, because of evolution.
Oh my gosh. So cool. I love it.
Okay. Anyway, thank you for visiting the Oakland Zoo. I hope you've learned a lot about genetic variation.
This is the Oakland Zoo? How did I get here? Okay. Bye. Thank you for teaching me everything.
And so class, that was the end of our lecture. Annabelle, what did you learn today?
That a gene pool is many different genes in a population, and relative gene frequency is how much of that gene is in a population and how common it is. Yeah, and mutations they happen when it's a permanent change in the genes, and it can be passed down to the rest kids. Gene shuffling, it's when genes are created as a like your mom and your dad together makes you and then your sister, but you don't look exactly the same because you guys aren't twins. Polygenic traits, they are traits that are controlled by genes that are not allelic, like size, I think. Directional selection is when one phenotype is favored over another, like an extreme one. So like a small dog, it dies off and the other super big one and super tiny one stay alive. Stabilizing selection, it's like the opposite. So when the medium is still there and the other ones die, like the big one and the small one die, right?
Mm-hmm. Good job. You got 100. You don't have to take the final now.
Yay! Thank you.
Blue side, back to the blue side.